GregsTutoringNYC at gmail.com. You can see my email path at the top of the screen there. It's also in the description below. So we're going to continue on with part 5 of the ISEE examples. And by the way, for anybody who's taken the ISEE, these are the actual samples provided by ERB. So this is a good run-through of all the examples, at least the math ones. I have to look at the English ones to see if we should do those as well. Anyway, we left off yesterday on a certain part, so I'm just going to jump right into this. Remember to like and subscribe, guys. Share it to anybody else you know. If you have chat rooms or something, pass it along. Because the more we spread this out, the better off everybody can be. The SHSAT is actually a very hard test. Some people say it's easy. I think it's very hard. So the examples, we have SHSAT-like ISE examples. So they're not as hard as the actual SHSAT, although some are, but the majority of these are simpler. So we're just trying to focus on basics for right now. I started the series out. Part 1 was the lower grade. This is the middle grade one. In the description, the bottom of the description has a link of how to get the document that I'm using to go through. The problem is it only shows the answers. It doesn't show how to do them. So that's probably what we're going to do. And eventually we're going to move into the upper grade one and do some of those examples. I actually haven't looked at it completely yet, so we may skip some if they're too hard because they're really more like SAT level examples, and they might be on math that are completely above the auspices of what the specialized high schools are about, and even about obviously getting into the SHSAT. The DOE claims you're supposed to know grade 7 and grade 8 math for the respective grade 9 and grade 10 entries. I don't believe it 100%, but that's what they're trying to match in recent years. Anyway, let's jump into this. It looks like I'm live. Everybody's good. I had a microphone problem with some of the earlier streams. I think I solved that, and the stream looks like it's flowing, so I'm just going to jump into this at this point. Let me move me to the side. I have a habit of not bringing this in this area here where I write into the screen, so you guys tell me when I seem to be forgetting to do that. I'm on a Mac right now, and I have to switch between screens. So this is the problem where we left off yesterday. So let me bring that up on my screen. This is the last problem we did. So just read the description on the top, because this is a little different than the way the SHSAT is laid out. So what we have is column A and column B given in all the answers. And what you have to do is evaluate it and figure out the value of whatever they're asking for column A is, and then the value of whatever they're asking for in column B. And then if A is greater, the answer is A. If B is greater, the answer is B. If A and B are equal, the answer is C. And if you think there's not enough information or something's distorted in what they provide you, then the answer is you can't figure out the answer. So it would be D. Okay? All right, so let's go up to 27. Let me just make sure this is all fitting on the screen properly. Yeah, I believe it is. So 27 has 2 diagrams. When I have a math problem, as I stated in some of the things, I didn't really expound on this yesterday, but when I see an illustration, I work from the illustration and then go backwards to the words. Often there's a sentence or two before an illustration, then the illustration, then some more words. In this case, it starts out with an illustration and then words. But I always like to start with the illustration. So let's analyze this. It has Mary's normal route. We see a square with 4 arrows pointing. It seems to indicate a direction, so Mary must be walking somewhere. So it shows a square 500 by 500. That's how we know it's a square. It doesn't show us right angles and so on here, but let's assume it is for now, and then let's work on the problem and see how it changes that. And then it shows Mary doing a shortcut. It shows one length is still 500, and it shows some 250s. Again, we don't know if they're right angles. And normally, you know if it's a right angle because it'll put a little square in like this, guys, if you're not familiar with that way of doing stuff. So it doesn't have to say it as long as you see that little square there. And make sure you don't think if it's a curved line like this, that this one does not mean it's a right angle. It has to be a little square and here. Okay? So they don't show that. So there's not much more information they're giving in the two illustrations they're using. So let's see what the words are now. It says in the diagrams, all angles that appear to be right angles are right angles. All right. So let's work with the two things they give us. So this appears to be a right angle, so it is one. This appears to be right, so it is one. This appears to be right, so it is one. And this one does. And they tell us this is 500 feet. And this is 500 feet. We're given a second one. I'm going to draw it smaller. I should have. Hey, let me do this over so they can both fit on the same place. Okay, that's that one. And then one next to it looks like it would be congruent otherwise, but they don't tell us they're congruent. But they sure look like they're drawn to scale. But remember in the SHSAT and many other tests, you can't make an assumption about that. So they give us this is 500, this is 500, this is 250, and this is also 250. So the question is, column B is 200 already. They're giving you that. So how do we figure out what column A is? It says the distance Mary saved by taking the shortcut instead of her normal route. So we're not sure where Mary started. She could start in any corner here. She could also start in the middle of one of them. So let's assume she starts in the lower. Let's assume she starts here at point S. I'm going to call it point S. Okay, and actually, let me make this easier. Let's say this is point S, and that's point S. Or S prime, let's say. So what is the distance Mary saves by taking the shortcut? Anybody have any ideas? Okay, this one seems to be a perimeter problem. So on the one on the right, I'm going to call this A, and this one B. Not to be confused with column A and column B. So let's call it A and B. So in AA, the perimeter is 500 times 4. It's a square. So you have 500 plus 500 plus 500 plus 500. So we get 2,000 feet. Question is, what's the perimeter of this? Do we know? Well, we know this whole thing here is 500. And this is 250. So that means this here also has to be 250. Okay? With the same way we know this is 500 and this is 250. So this must also be 250. The problem is we do 500, 500, 250 and 250 is 500, and 250 and 250 is still 500. So she saves nothing. She saves nothing. So 200 wins here. Okay, because it turns out both perimeters are the same amount. Right, so she thinks it's a shortcut, but it's actually not. All right, so this one could be a teaser SHSAT question. It could be a field question. I don't know if you guys know that there's 57 questions in each section. Okay. 10 questions a field in each section. So you basically end up for 47 questions in each section that actually get graded. So there's 10 questions, there's 10 out of 57. So if we do 10 out of 50, there's basically about 19% of questions in both sections are not graded. So sometimes this is related to your pacing. You have to decide which questions are worth spending more time on or not. Anyway, this one is an easy peasy enough one. Just remember when you do easy questions, these are the ones that you're going to make silly errors on. So you're going to think, oh, this is so easy, and you're going to do, you know, the perimeter wrong in this example. So just be careful with stuff like this. So the problem with the hard ones is they're hard, and the problem with the easy ones is they're easy. So don't get sloppy on things like this, and write down as much as you possibly can. Don't do math in your head. A lot of people say, well, once you're comfortable with it, you know what, this is a high-stakes test, and if you get time to come back and do double checking, you may have forgotten what you did the first time through. What I like to do too is to solve a problem a different way. There's no other way to solve this problem. It's just what it is. There's not really a second way to do it. So, but when there is, you should do it so that you can double check your answer. And by the way, you should be doing stuff in your head maybe for estimation, because at the end of something, you should always ask yourself, is the result I got making sense? You know, if we got the column A was 10,000 or something, you have to have a mathematical sense to say, like, this doesn't make sense, it's too high. Okay? If it's close, you don't know, but that's what estimation is for. Okay? All right, so let's go to 28. 28 is another one that's not really at the depth of a SHSAT question, but it's still testing your ability to read and make sure you're understanding this, because part of your mathematical accuracy is your reading accuracy, making sure you understand what the problem is saying, mapping words into math, right? All right, so 28 says, Kerry is driving from town A to town E. Let me just make sure this is showing on you guys' screens. Yeah, it seems to be. She's going from town A to town E. She must travel through town B and C and D in that order. Okay? Let me get another piece of paper. So we don't know if she's going in a straight line or a circle or what. It really doesn't matter. That seems to be not a significant aspect to this. So let's just do it in a line. So she's going from A to E. Okay, it says she must travel through B, C, and D in that order. So you know, we could have made this where E is maybe just before A, and she goes around this way. Okay, that doesn't matter. We're just going to express it linearly, because it's saying she's doing it linearly. All right, so we have a thing here where from A to B is 135, from B to C is 55. What I'm just doing is labeling stuff, taking things one at a time. C to D is 110, and D to E is 86. Okay, so it says Carrie has just arrived in C, so she just arrived right here. So how much has she gone so far? She's done 135 plus 55, which I believe is 190, right? And the amount she has left to drive looks like it's 196. 110 plus 86 is 196. So the total so A is the total number of miles she has driven, and B is the total number she has left. Okay? So we could do the math on that, but the obvious answer is that the total number of miles has to be greater than the total number she has left. Because we're not comparing the 190 to the 196. A lot of kids are going to read that because it says she stopped at town C, as in the total number of miles she has driven. Oh, sorry, it does mean that. Okay, it does mean that. So it's the total number of miles he has driven already, not that she's going to drive. So she drove 190 and she still has 196. So the total number of miles doesn't matter. So this is a little, it's about reading the problem. The total number she has driven, she's driven 135 and 55. She still has to drive 110 and 86. Okay, everybody good with that? Okay, this is a shaded area one. This kind of problem can be on the SHSAT. It's simple enough, but it involves looking at things a little deeper as well again. So I'm going to try to draw that with my drawing skills being atrocious. So it looks like we have a square. It doesn't tell us that as far as I can see. We have two diagonals. And there seems to be an inner square. Okay. And here's what I'm going to do so we can talk about it. I'm going to make this A, B, C, D. And we have E, F, G, and H. Probably should have drawn this a little bigger. So what we have shaded is B, C, D, and this little area here, which is H. So it's asking us, is the area of the shaded portion of the figure larger than the area of the unshaded one? So what I'd like to do is, because this is shaded here, I'm going to kind of split out that trapezoid. To more or less be like that. Because I'm doing that because this is shaded in. And if we move this to say here, if we move the shaded one there to here, then we notice we have to fill in at least two more of these to see which one is greater. We have two more here in this. So we can see from that it's greater. We can also just shift this one into here, move the shaded one here right into that one, and then we're almost filled in except for this. So it's clear that this is smaller than this whole area here. So the shaded area wins no matter which way we look at it. Is everybody good with that? You could also do areas of trapezoids and areas of triangles and so on. It's not worth doing that. This is really just a visual problem. Some problems should be solved mathematically. This is also still being solved mathematically, but spatially, through using space. We're just getting a sense of spaces without knowing that it's really squares, without knowing that it's really triangles, stuff like that. So we have a whole bunch of congruent shapes in here and similar shapes. Looks like there's a whole bunch of similar triangles and there's a whole bunch of similar trapezoids, and they're probably congruent. So we're using that capability here. If the figure was slightly different and the shading was closer, then we may have to start breaking out numbers and testing out things like that. We could test out brute force stuff, or we could say the length of the side of the triangles is 1, and the diagonal of the square might be 4 or something like that, and actually start computing numbers to see literally which shaded area is greater than the other. Because you should know the area of a triangle and how to do the area of a trapezoid. Okay? The SHSAT does not give formulas, neither does the ISEE. The area of a triangle is 1/2 BH. And the area of a trapezoid is equal to the 2 bases over 2 times the height as well. Okay? That should be base 1 plus base 2. Get the average of them. It's basically taking a trapezoid, cutting off the triangles, and putting them together to make basically a super rectangle. And we know that the rectangle is 9 times width. Okay? It's okay. I'm chugging along either way. All right, so 30. And I'm not sure 30 is showing on the screen, so let me move over the thing I write with, the writing area. All right, there we go. So again, I'm going to look at the figure first and just try to make sense of what the figure is without looking at any words. So I see a spinner. The spinning needle is between 3 and 4, and the ISEE, that's the style they use. Some other styles might put it actually on a number, but we don't want to get swayed that because the figure might be pointing at 4, it's actually at 4. So they put it between 2 numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 locations, right? And they all seem to be equally distributed. So we have to make some assumptions that it's a fair spinner, meaning it's not biased in a certain way, that the needle might be heavier on 1 and 2, or the pie shape number 8 might be larger than the others or something. We have to assume it's a fair spinner, that it's all balanced out properly. Okay. On some tests, they actually use that word, a fair spinner, or something like that, some notation of that. So now that we looked at the thing, there's really nothing more to do with the illustration. So let's get back to the words. The spinner is divided into 8 equal-sized parts. Okay, that's kind of what we confirmed already from this analysis. So for any one time, the spinner is spun, the probability of spinning an odd number. So we have 1, 3, 5, and 7. 1, 3, 5, and 7. Right? There's no other odd numbers. So our probability there is 4 out of 8, or a half. Okay? For B, it says for any one time, the probability of spinning a number less than 5. Well, that gives us 1, 2, 3, and 4, which is also 4 out of 8, which is also a half, and these two are equal. So that means the answer would be C. We're doing column A. I'm not sure which problem you're at. We have to always do both columns, though. Yeah, I don't know if you wrote that for the previous question or not, so sorry. All right, so is everybody good on this kind of spinner thing? So this is really just testing fundamental stuff, but again, you can mix up here. And the good thing about solving the problem at this level, again, we're going to eventually move to the upper level, but if you can get it at the medium level and the lower level, and you can make errors. Everybody makes errors. This is the point where you should be making sure you're cool on the fundamentals, because there will be spinner problems that will be harder than this. So if you're going to get this one wrong, you're going to get the more involved one wrong. Not probably, right? So you want to make sure you have your fundamentals down on this kind of stuff. Because when you have a harder problem, you want just the hard problem in and of itself to be the challenge. Not like, whoa, how do spinners work, right? You should already know that kind of stuff, and you should know it well. All right, so let's go to 31. Let me make sure it's showing on your guys' screen. Yeah, I think it is. So we have 9 cards numbered 1 through 9 are put in a bag. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are put in a bag. So we're going to do A versus B. Okay, A says the probability of choosing an even number. So we're going to have 2, 4, 6, 8. So we have 4 out of 9. That's the probability there. Okay, B says the probability of choosing an odd number. So we have 1, 3, 5, 7, 9. That's 5 out of 9, right? So column B is bigger. Okay, again, it's a simple one, but it's just mapping the English to math and doing it. And this is the kind of thing where you want to do this on paper, because it's easy to do this in your head, and probably get that they're both 4 out of 9 or they're both 5 out of 9, and forgetting how to count in your head. You don't want to do this. You definitely want to write it down, and you definitely want to double check an answer like this too. Just make sure you wrote down all the even numbers and all the odd numbers. All right. Okay, this is using the same A and B thing. There's often a number line question. Let me just make sure if the thing is not interfering with what you guys are saying. Okay, I don't think it is. It's not showing on my screen yet. There's about a 30-second lag here. Want to make sure it comes up. So again, we're going to look at the illustration first. In this case, it's just a number line. It seems to be that the number line is called L, and that there's 2 points, R and T on it. There's really nothing more we can see there. If it's a standard number line, it means R is less than T, or T is greater than R. Okay? So let's go back to the words. R and T are points on line L. Okay, it doesn't say number line, but we can consider it as one. S, point S, not shown. So we have line L, we have R, we have T, and it says S is a point on a line between R and T. So it could be right here, and it could be also right here, or it could be somewhere here. So I'm just going to put it in the middle, realizing it could be from here all the way up to here. Up, but not including R and not including S. So if R might be 1, it could be 0.999999, right? And if T is 2, it could be 1.999. It could also be 1.5, all right? So we don't know. It's just in the middle there. So then it says, column A is talking about the distance between R and S. So is this distance DRS compared to the distance between S and T? Which of those is greater? Well, we don't know where S is, so we don't know which is greater. So this is one of these answers where it would be D. Again, the SHSAT doesn't have this style of questions, but it might have A, B, C, D in this answer choices. And it might say the distance of RS, the distance of ST. It might say RS is equal to ST, or it might say unknown, right? So we can still get an equivalent structure on the SHSAT doing the same kind of setup. And in the SHSAT, the answer would be D, unknown. All right, they have a reading comprehension part. We're going to skip that. Okay, so we're going to start to do another part. Probably we'll go for another half an hour here. Depends how things are flowing. YouTube seems to be working with us today. All right, let me shift some of this stuff over on the screen because the formatting is slightly different now. So now we're getting into normal SHSAT style questions where we're giving raw math now. The earlier questions on the ISEE are kind of intended to test your logic, and really only the logic, and quantitative stuff. This is actually getting into a numeric sense more and things like that. Still need to solve deeper questions and so on, but there's a slight difference in how they view these two different sections. All right, so question 1 is kind of a no-brainer. We have 9876 plus 6789. It's really just about adding those two. Problem here is the answers are all similar. On a problem like this, sometimes we can just add this column and be done with the problem. Because 9 plus 6 is 15, and we realize that it has to end in a 5. But it turns out all the answers end in a 5. This comes in more handy when you have to multiply two numbers. So if I had 1, 2, 3 times 4, 5, 6, we know we're going to get an 8 in this column here. So if an answer only has an 8, we don't need to do all the other calculations. This kind of scenario comes up often. But in this case, it's forcing us to keep going. So if 8 plus 8 is 16, 1, 8 plus 8 is 16, 1. We get 15 as 16. So I get 665. So the answer is D. Okay? If I did that right. What I like to do is, there's a way to double check this, which is to invert it. So do 6, 7, 8, 9 plus 9, 8, 7, 6. Okay? By the way, in your multiplications, you can also double check it by inverting that as well. You're going to get a different scenario of additions and a different scenario of multiplications. And if you get the right number, the chances are better that that you did your multiplication and or addition correctly. Not a guarantee, but it's a closer shot to doing it. So this would never be asked on the SHSAT question number 1. Again, we're at the middle level ISEE, just making sure we're reading the basics. Somebody might read that problem instead of a plus sign and think it was a division or something like that, or whatever. I don't know. You know, you're under testing conditions, so now is the time to prep and get used to these kind of questions. Okay, number 2, which expression is equal to 20? So this is understanding PEMDAS. Parens, exponents, multiplication and division, and this is addition and subtraction. These are done together from left to right, and by parenthesis we mean parens, we mean brackets, we mean square root, we mean there's probably other choices here. So when we see A, B, C, or D, which is the ones? So we have parens, so we're going to do 5 times 3 first. We're going to get 15, plus 4 is 19. So we already know we can't get 20 here. We're going to do B, 5 plus 4. We're going to do that first because it's in parens. We're going to get 9. Then the next thing PEMDAS tells us to multiplication. So we have 9 times 3 is 27, and minus 7 is 20. Okay, so it looks like we got the answer. B is 20. A lot of kids would stop here. I say do C and D anyway, just to make sure you didn't make a mistake. And if you end up getting 2 answers of 20, then you know that one of them is wrong, or maybe even both of them. Or maybe you're approaching PEMDAS, or maybe you're not even using PEMDAS and you don't know what you're doing. Okay? So C turns out to be, we do parens first. We get 4 minus 7, we get minus 3. Then we do multiplication, so we have 15 plus minus 3. And we get 12, so that's not it. And then this, and D has 5 plus 4 minus 7. In parens, we do plus and minus left to right. So we have 5 plus 4 is 9, minus 7 is 2, and then all of us basically 3 times 2, we get 6. Okay? Okay. So we're going to look at the figure without looking at the words first. We have a circle. It's divided in half, and that half is also split into a number of different pieces. And it looks like it's split into 1, 2, 3, 4, 5, 6, 7, 8 little tick marks. We see there's some tick marks around here going like that, kind of making a sun out of it. So I'm assuming they're equally dividing the circle into parts. If we did that to it, that's where the tick marks come in, right? So what they're telling us is they shaded some of that. They shaded this here, and they shaded this here. So we basically have this half is unshaded, and we have a part here, and a part here, and some part here. So now let's go back to the words. The circle shown is divided into equal parts. So we know that this here, let's call it X, and this here, y, we know x equals y, because it's telling us it's equal parts. We also know the angle inside of here. We can call that angle x, and this one here is equal to angle y. All right? So then they ask us, what part of the circle is shaded? Well, they already split it into eighths, so we really just have to look at 2/8. Okay, and that's a good habit to actually draw through. But you can also look at it and see that this half is not shaded. So we're left with another half over here. And the question is, between this and this versus this area here. And maybe a handy thing to do is you're allowed to turn your paper. And if you did that, you could see that this kind of looks like a 90-degree angle. They don't tell you it's 90 degrees. There's no little square in there again. But you can kind of deduce it was. And you can actually know it was because it tells you, when you go back to the words, that they equally split apart. So we know that 2/8, because there's 8 parts, equals a quarter. So that's 1/4. So a quarter of 360, because the circle is 360 degrees, is 90. But again, remember, you're allowed to turn your paper during the test. You know, don't distract everybody else. You can just turn it gently one way or the other. So you can kind of get an insight into the problem. Oh, that looks like it's 90 degrees. Let me see if I can figure out a way to show and demonstrate that it really is 90. Okay? So the answer is B. A quarter of the circle. Okay, 4. Which number has no positive factors except 1 in itself? So this one is easy enough, but it's enough that some kids are going to get wrong. They could have used harder numbers here. They didn't. Probably in the upper grade one they will. So let's just run through them. 8 is even. So we know it has other factors. It has 1, 2, 4, and 8. Okay? 15. Some kid's going to say, oh, divides by 2. No, it doesn't. And then they're going to just be left with its factors of 1 and 15 and totally forget about 3 and 5. And just answer B because it's the second one and not try C and D. And as I mentioned before, our strategy is once you get the answer, try to solve the other ones, especially when it's an easy problem like this. If it involves a lot of math, that's a different story. And there's often another way to double check these numbers. Okay? By the way, you should know your division by rules. You should know how to check for a number's division by 2, by 3, by 4, by 5, by 6, by 7, by 8, and by 9. There's a whole bunch of rules for that. So if a number is divisible by 3, the sum of its digits adds up to 3. So take 15. This means 1 plus 5 equals 6. 6 is divisible by 3. Therefore, 15 is also divisible by 3. Okay, and each thing here has similar rules. 9 works the same way. The sum of the digits of a 9 number, okay, is also that. And if we have a large number like 1, 2, 3, 0, right, we can add the sum of the digits, and we get 6 here. So we know this is divisible by 3, just by doing that. And if you have a super large number that ends up doing something like equaling 1, 2, 3, 0, you can reapply the rule. So let's say this, I don't have a number up to the top of my head. There's a whole bunch of 9s, and when you add up the digits, you get 1, 2, 3, 0. You can reapply the rule, and you get 6 still. So it would still show that it's divisible by 3. So in fact, you should go to 10 and to 11 as well. And this comes up often in standardized tests. By the way, there's also numbers like 17 times 3, or 19 times 3, 16 times 3. You should know all those numbers. These come up often in standard tests. And not necessarily 16 times 3, but 48, or 51, or 57. 57 looks like it's not divisible by anything, but it is. Because you're going to get 30 here plus 27, it's 57. So they might use 57 on a lot of tests. Okay, or 570 or something like that. Especially on a question that's kind of like this. So getting back to the question, 15 has more factors. There's 3 and 5. Then we get to 27. It's not divisible by 2. Again, a lot of kids would give up. But if we work this out, 2 plus 7 is 9. That's part of the division by 9 rules, right? This is also divisible by 3. So 27 is divisible by 3 and 9. So in other words, anything that's divisible by 9 is also divisible by 3. So that turns out to be some of the factors: 1, 3, 9, and 27. And then we finally get 31. We know it's not divisible by 2. Is it divisible by 3? Well, 3 plus 1 is 4, so no. And what about 4? There's rules for 4, but we could see if it was 30, we would end up getting 15 and then 7.5. And 7.5 is not a factor. We're normally talking about whole integer numbers here, including negative numbers sometimes. All right? And by the way, question number 4 is asking only for positive factors, not negative factors. And by the way, when you read question number 4, a number that has no positive factors except itself and 1 is called a prime number. All right? So 31 is a prime number. So it turns out that 31 is the case. And if you went through this a little quicker, you can double check. And again, you want to make sure that 31 really isn't divisible by anything. But that's the way to do that. Okay? So the answer here would be D. All right, this is still showing on the screen. That's good. Okay, question 5. So we're going to look at the diagram. There seems to be a scale that's balanced. It looks like one side is not heavier than the other. And there's some little balls or something on the left side and some sort of triangles on the right side. Again, they seem to be equal. So if we're going to count them, it seems like 5 balls is equal to 2 triangles. We know that because the scale seems to be centered. Okay, we're not exactly sure, but that's the best we can seem to get out of the example for now. So if we go and read the words, use the diagram on the balance scale to answer the question. So in the figure shown, if 5 ball equals 2 triangle, and 1 triangle is 15, what is the value of ball? Okay, so this is a good question. This is definitely a SHSAT style question. So 5 balls equals 2 triangles, and 1 triangle equals, 1 triangle represents 15. So that means 2 triangles would represent 30. Right? So that means if we bring this and this together, because it's talking about 2 triangles, this is equal to 30. So if we look at the ball as if it was x, 5x is equal to 30. So what we did is reduce this to algebra. And we can even keep it as a ball, so let's do that. So we're going to divide by 5 on both sides, and we get ball equals 6. All right, so it's just straight up algebra. It's mapping things back and forth. And you could feed some of those numbers in there as well to see which of those make sense as well. This is the kind of problem where it's hard to double check because it's just straight up symbolic. It's like if I said, 2w equals 10. It's clear that if you divide by both sides, you get w equals 5. You can't go too deep in double checking that. Although you should take the 5 and feed it back in and see if you get 10 back. So we can do that here. Take the 6 and get 5. 5 balls is 30. Are we really talking about 2? 1 was 15, right? So 2 must be 30. Yeah, that jives, okay? So just run through it all again as best you can. Okay, 6. I may only do a few more of these at this point. All right, the screen seems okay. So Elita scored an average of 10 points in each of the 5 rounds of a game. If her highest score was 18 and the range of her score was 12, what was her lowest score? All right, so let's see what we have going on here. So she did 5 games. The average equals the sum of the numbers over the number of numbers. So it tells us she had 10 points and she played 50 games. So the sum is going to be equal to 50. Her highest score was 18. And the range of her score was 12. That means her lowest score was 6. You just subtract the two of them. The range means the high minus low. So if this was 18 and the range is 6, then we know we get 12. Okay? And in fact, that's what it's asking. So this part here was a red herring. It's not really involved in the problem. And we just straight up get 6. Range is something you guys should have had from grade 5, maybe even sometimes in grade 4. And it's something that kind of gets thrown to the wayside. It may come up every year in class, but it's never really done seriously again at that point. But on stuff like the SHSAT, it could matter. Sometimes they give a table of ranges. They may give a scatter plot. They may give a leaf plot. They might give a whiskers problem. There's a whole bunch of different kinds of illustrations that involve understanding different numbers that come into play when you're doing averages and medians and stuff like that. So it's something you guys should be aware of. Okay, question 7. I'm not sure that's going to fit on the screen, so let me come back to this here. Nope, it does. Okay. All right, so we're going to look at the illustration first, forget the words. We have the temperature of each hour in the schoolyard. It looks like they plotted stuff at 9, 10, 11, 12, 1, 2, 3, and 4. So every hour, it looks like they plotted something. The bottom is time, so we know it's hour. And on the left-hand side is the temperature. So they plotted the temperature that was going on during the day. Okay? So what they want to know is the difference between the high and the low. All right, so this one's a no-brainer. At 2 o'clock was the highest temperature, was 70. And at 9 o'clock was the lowest temperature, 58. So we're just going to subtract the two of those and get 12. Am I doing that right? 70 minus 58. Yeah, we're going to get 12. All right. I'm going to double check that answer. Yep, it's B. Okay. Right, so 8 gets back to PEMDAS again. Some kids are only going to apply the 2 to the L and not apply it to the W. So if this is 1 and 2, they're going to basically do something like this and do 2 times 1 is 2 plus 2 is equal to 4. Does not have to solve that. This is distributive property. We have A times B plus C equals A times B plus A times C, right? This is something you guys should well know already. So we have 2 times 18 plus 10. And by the way, when we're given both numbers, so let me just do the distributive first. We have 2 times 18 plus 2 times 10. We get 36 plus 20 equals 46. No, 36 plus 20 is 56. What we could also done was, at this step, just add them together. So we have 2 times 18 plus 10 is 26. 28, and 2 times 28 is 56. So there's two ways, and we can double check our answer by doing this. Okay? Okay, 9 is an estimation one. That again also comes up often. This is probably too simple to be a SHSAT question, but it's asking for basically 89 times 91 divided by 800. That's a division sign, I believe. So what would the answer there be? So we basically have 90 times 90. We have 89 times 91 divided by 800. So this is basically, if we estimate 90 times 90, right? So we're going to get 8100 divided by 800. So this is about 8,000 divided by 800. And we can see the answer is just 10. So that's an easy one. Again, it's hitting home that you're able to map the questions back and forth. Okay? Question number 10. Annie and Daryl make the table shown to keep track of their savings for 4 weeks. So let's look at the table. Annie and Daryl's savings, week 1, 2, 3, 4. Annie goes 240, 420, 6, 780. Daryl goes 485, 76, 60, 750. Okay, after week 1, how much did Daryl save each week? So this is really just looking at the table and subtracting some of his numbers. So we get 570 minus 480. And we can see already that's just 90 cents. If this is 70, it would be $1 and it's 1 up. So we could do the subtraction too. So we get 90 cents. So let's confirm it's true between 3 and 4. Is 660 plus 90 cents? Is that 750? Yeah, it is. So the answer there would be A. Eleven's another one that's just number sense. Okay, the SHSAT question would be harder. And there's a couple of ways probably to solve this just looking at this. So what we can do is straight off the bat, we can divide this, just get 20 times that. All right. So 48 plus 52, you can do that in your head, but might as well write on the side. It looks like 100. Again, I would flip it just to be sure. Even on something as simple as this. 8 plus 2 is 0, and we get 100. So we had 20 times 100. So we get 2,000. All right. We could have also postponed this division up here. So let's look at that. We have 60 over 3. 48 plus 52. So we still have to do this addition. So we would get equals 60 times 100 over 3. And that would become 60 times 100. We should get 600 plus the 0 over 3. And then do the division at the end and get to 2,000. So we tried it 2 different ways, and we still got the same answer. All right? Let's see, how many questions are here? 30. All right, I've been going about an hour at this point, so I think I'm going to end this. Again, like, subscribe, share the video. Let me bring my email back. Again, it's in the upper left, the upper corner here, right here. It's also in the description below. as well as the link to the file I'm using here. And it's about looks like another 30 questions. So add a part 6 at some point. Maybe do it tomorrow morning, tomorrow night. Maybe do it Monday. Have to see. All right, everybody. Hopefully everybody has a good day. It's been too hot for too long, but in any event, peace out, guys.